So the test is 35 questions, multiple choice. Again, those are 2 points apiece. And then there's 7 that are graph / open-ended, like you're verifying. Those are 4 to 5 points apiece. You're going to start with the calculator portion. I think there's 5 questions, but it's short like that. And then you will put your calculator on the ground. You'll get the second portion, and that's where you'll start. The first part is even still multiple choice. The open-ended is not until you get to the end. Those you'll do right on the paper, and then everything else you'll bubble in on an answer sheet. There's 42 questions total. My goal is to give you 90 minutes. Your schedule goes from 7:56 to 9:50. Then you get a break from 9:50 to 10:10. And then the second class is 10:10 to noon. Can you say it? Yep. I'll actually put it on here. Hang on. So it's 7:56 to 9:50. And then 10:10 to noon.
Okay, I guess I have an hour before practice.
So 12:10 to 12:16. Okay. So Friday's AC exams. Monday is block review. Tuesday is block test. Wednesday is IJ review. Thursday is IJ test. And there are I will review with you on Thursday. Wednesday. So if you are those people that are like, oh, my teachers don't do anything on review day. If you had that experience before, that is not me. I will go over whatever questions you have, and then I have 2 interactive reviews for you to do that are extra reviews. So if you are that type of person that's trying to be lazy and stay home and miss a review, and you tell your parents they don't do anything on review days, don't be a liar, okay? I will review extra with you on Wednesday. And then Thursday, you take your test. Only kids that need to be on campus on Friday is if they need to take a makeup. Other than that, you have a very Merry Christmas, okay? And if you are exempt from all of them, then your last full day is Thursday. Sorry, I didn't mean that to hurt your feelings. Yeah.
That is so sad.
All right, now we're going to go through. So for B1, so number 1's B1. You need to know both those formulas, midpoint and distance. The midpoint is x1 plus x2 over 2, y1 plus y2 over 2, and the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. The graph, number 2, would happen in the graphing portion of it, so it would be towards the end of it. Okay, this isn't necessarily the order of your exam, and you'll see it jumps around from section to section, so it's not one fluid thing, because that's what a standardized test should do. So 2, graphing the line is 1, 1, and it sounds ridiculous, but I have gotten to the point where there are pre-calc kids that could graph cosecant perfectly and then screw up the line. Don't do that, okay? Start at B and then use your slope to get the next points. Number 3 comes from 1, 2, and this is your domain. So with your domain, remember domain is all real numbers except for one of these 3 cases. If there's a variable in the denominator, and for that we set the denominator not equal to 0. If there's a variable under a square root, and for that we set whatever underneath the root greater than or equal to 0. And if there's a variable in the denominator under the root, in which we combine those, so we set it, whatever's underneath the radical gets set greater than 0. That will be in interval notation. Hang on. Okay, then 4 and 5 come from 1, 3. Does what say? No, that's B2. Yeah. 4, 5 come from 1, 3, and 5 is not a multiple choice question. I've seen people just circle one of those. That's not what that's supposed to be. Okay, it is a multi-part question. You are not going to get a multi-part question like that, obviously, on your test, but you could get any one of those 6, so you want to be prepared for any one of those 6, okay? So on there is adding functions, subtracting functions, multiplying functions, dividing, and then the composite, the f of g's, whether it's a variable, or the f of g's where it's a value. So all of that's in 1, 3. And that's why you review.
It's not coming back.
Yeah, and that's honestly why midterms are not the worst thing in the world. Like, happy for those of you that are exempt. Yay for you, but there's no retention in a lot of that information, so the mid-year review is good. 1-6 is your inverse, okay? So this is the one where in the green there it says you're going to, step 1, change f of x to y. Step 2, switch the x and the y. Step 3, solve for the new y. And then step 4, you replace y with f negative 1 of x. On that box? Yeah, sure. All right, 7 is B2. This is your circle. So the equation for your circle is x minus h squared plus y minus k squared equals r squared. HK is the center and r is the radius. So we change the sign on what follows x, you change the sign on what follows y, and you square root r squared. 8 and 9 are 2, 4. This is where your complex numbers came into play. So you're going to be adding, subtracting, multiplying, dividing with your complex numbers with the i's. Remember, I squared is negative 1. But other than that, it gets treated just like a regular variable. Standard form is a plus bi, where the I comes last. That's all that means. And again, that would be multiple choice, so you can't screw that up. Like 2 plus 3i and 3i plus 2 are not going to both be answers.
I forgot to write the
It's
1
okay.
point something.
This thing?
Yeah, so, oh no, the B1.
Oh, B1 midpoint distance.
And I emailed Mr. Saxon, he never got back to me.
Oh, I emailed him back. He forwarded it to me, and then I emailed him back. Do you know if you would be active or associate? Are you in your 5th semester of honors?
I think so. I took honors first.
Geometry, right?
Yeah, review, and then I took algebra 2 honors.
Oh, then yeah. I'm just gonna freaking add you.
Okay. Yeah, because like I even have the proof that I paid too, because I was
He wrote me back and said she's paid. But then I was like, okay, but is she active or associate? Because I didn't want to look up your schedule. I thought maybe he would.
Oh. Okay.
He's usually the boss of that stuff, but I didn't have, I know you have, I
Yeah,
had
so I guess I'll just start next semester.
Well, you can still, I mean, start whenever you want to start.
You want to see what I did by myself?
Yes.
Okay, look. Let's go to the first page. I did the whole first page by myself, right?
Good job.
I did 3 questions on the second page. 1 question on the third page.
That's a good start.
4 questions.
It's a good start.
2.
What?
0.
Yes.
Like on the graph, I only did 1 graph, and then I forgot about the graph, and then I did basically the whole last page.
Oh. Wednesday.
Yeah.
Wednesday, I'll give you ours.
Child is part of it. Anna, what's your, hang on, Anna, what's your ID number?
26156.
But you were not inducted, no, this is your first year. Never mind, ignore me.
It's gonna be this one that's gonna be posted tomorrow.
Say again.
It's gonna be this that's gonna be posted
The
tomorrow.
solutions to it. Yep.
And it has all the little notes on it too.
It has all the things. Wait, say it again.
It's gonna have like all the little notes, like stuff like that.
No.
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 Okay. Did you go to
Which one?
15?
Oh no, you got me started over.
All right, 2, 4 is this is where you have an I in the denominator, right? That's like having the square root in the denominator can't stay there. So we multiply both the top and the bottom by the conjugate. 11 is back from 2, 1. So 2, 1 was the start of your higher degree. Actually, 2, 1, sorry, is quadratics. This is finding the max or the min. So you got to find the vertex. We find the h coordinate of the vertex by plugging or by doing negative b over 2a, and then we take that value, we plug it back in to get k, which is the y coordinate of your vertex. This question actually says find the coordinates of it, so this answer would be an HK scenario, okay, XY answer. If it just asks for the max or the min, it's just the k.
Can we get lots of data hours?
If you get to work with somebody today, yeah. 2, 2 is the leading coefficient test. This is our end behavior. So remember, we look at the highest exponent. If it's even and positive, both of my arrows point up. If it's even and negative, both my arrows point down. If it's odd and positive, it falls left and rises right. And if it's odd and negative, it rises left and falls right.
Oh my gosh. I tried to help somebody with I was in honors with this, and I just.
Remember, it's just like it takes on your, so like if it's even, it takes on the properties of a parabola, right? If you had a positive x squared, it would point up, and if you had a negative x squared, it would point down.
Yes, but
And then this takes on the x cubed. If it's
See, but-
positive, it points up to the right and down to the left, and if it's negative, it points up, left, down, right.
I just couldn't
Hmm? Yeah, this is 2-1. Or 2-2, sorry. What?
I basically forgot everything on chapter 2 except point 3 and point 4.
Okay, so maybe you want to review that chapter. 13 is your zeros. We said f of x. We plug 0 in for f of x. So you solve. This is factorable. Okay, anything that's raised to, anything that's got 4 terms, you want to try to factor it. This is factoring by grouping. And then 14 is your roots and your multiplicity. So remember that one we solved to get the zeros. And if that answer occurs an even amount of times, it bounces off the axis, or the wording is going to be touches and turns around, because this is multiple choice. So it's going to say touches and turns around. It's the same thing as bouncing. And if it's odd, it crosses through. Yeah, that's what bounces mean. Like it hits the axis and turns around. So if you had 2 zeros, right, then the multiplicity is 2 and it's going to bounce there. Or touch at 0 and turn around. 2, 3 is 15, 16, and 17. This is our long division, our synthetic division, and then applying the synthetic division like something like 17, where if you're given the 0, you're going to put that 0 on the outside of your synthetic division. You're going to reduce your function a degree, and then you're going to either factor what's left, or you can use the quadratic formula. So you use the root given on the outside of the synthetic division to reduce it, and then you can either factor it or use the quadratic on the quotient. Quadratic is negative b plus and minus the square root of b squared minus 4ac all over 2a. I don't know why that c is there. 2a, not 2ac. That thing?
Yeah.
Yeah.
You already said problem child.
No, it's not problem child.
But it looks like problem
No.
child.
The question is important. You're actually very warm.
Really close. An orphan.
No. It's a Christmas song.
It's a Christmas child. What child is this?
Yeah?
Oh! Yeah, there we go. Oh, they already knew. Oh, is that you? Make fun of my feet. Make it look good. Oh, okay. Guys, sign. Okay, so when you find the circle, it's where sign. Like instead of doing that's an -1 and like -1, you're gonna get if there's no -1, then you're gonna get the actual okay. And then for where is the angle? I get an hour, right?
For what? I'll give you an hour. We'll do tomorrow since it's like so short right now. I'll give you for 5 minutes. I'm gonna say you could save the hour for tomorrow. 5 minutes not equal 60 minutes. But tomorrow will also be less than an hour, but I'll give you the hour for the two combined. Tomorrow is math. This is like rejoice. I love Jesus.
I don't want to sit there. I have to sit. I have to walk up there. And then I'm not Catholic, so I can say it. And I have to sit.
She's only saying that because she's injured.
And then I have to go up there. I'm Christian.
So what? So you're still going to heaven just now? Is that what does that mean?
No, I just.
You're still a good person?
Huh?
What? Like, because that makes you still a good person?
No, it's just like, it's like when this thing is at a Catholic class, I don't get anything out of it because I don't understand. I know where you fit. Like, I wasn't raised Catholic or that.
But some of the homily lessons are just about being good people. They don't necessarily have to be specific to Catholic.
No, I know, but like, I just don't understand. Like, the Catholic class, I don't understand what's going on. Like, when they like repeat the verse, like, I don't know when to repeat anything. Like, what am I doing? I just feel like dumb.
Bye, guys. Have a good day.
What is LC?
The leading coefficient. It will be on the video too, Brandon. It's just obviously it's not on the solutions because some of it might be, but not necessarily the same.
Yeah. I'm just writing down everything.
Okay, you're fine.
If
Yeah.
we're exempting, do we have to do the whole review?
I have 3 hours. 10 more hours. Actually, 9 more to go.
All right, so 20, these are your graphs. So these would be at the end. This would be on that open-ended portion, right? So the graph, when it's exponential, you're plugging in for the x's. So it would be -1, 0, and 1. And then set up your t-chart, plot your points, graph it. For 21, this is from 3, 2, because this is the log. For these, remember, we convert these into exponential, and then we plug in for the y. So the logs, you plug in for the y. So this is where you would make this y equals log base 5 of x minus 1. And then the 5 picks up the y. And then you'd add the 1. So you're plugging into 5 to the y plus 1 equals x. And you plug in to the y. And then just plot your points. With the exponential, there's a horizontal asymptote at 0 unless there's a vertical shift. And with the logs, it's at 0 unless you have a horizontal shift like this. So this would have a vertical asymptote at 1. It's not going to ask you for all the parts. It's just going to say graph. But obviously, those things usually help you figure out where that curve's supposed to go.
Wait, why is it at 1?
Because it's at 0 unless there's a horizontal shift with a log, and there is a horizontal shift because you got something inside the parentheses. Yeah.
If you have to change if you have to like, what you did for number 21, it's vertical. Is it like always vertical?
Yep. With a log, there's always a vertical asymptote. Yeah. Then the rest of this page is logs, right? And none of this is calculator based. So this is either expanding or condensing, and then using properties of logs. So with something like 22, I mean, hopefully we got to the point which we're comfortable and we could say, okay, what power do I raise 3 to get to 1/9? That's one way to do it. The other way is set this equal to x and then convert it. Remember, the base picks up the 1 on the other side, so 3 to the x would equal 1/9. And then change your base from there and set your exponents equal to each other. So I would change the bases to be the same. So I would bring 9 to the top, make it a -1, and then rewrite 9 as 3 squared.
Oh, okay.
Yeah.
And you so you're like finding x.
Right. But we brought in an x. So like the answer choices are just going to be numbers. They're not going to be x. And then something like 23, remember if you have ln of e, what happens? It cancels out and just get the exponent. So if I had ln of e to the 5, my answer is just 5. You take the exponent. For 24, 25, 26, and 27, the directions say expand, but it is also implied or condense. I don't know why this test generator likes to just say expand, but it's expand or condense. For 24, 25, and 26, there's only one log, so you would expand those out. But for 27, there's more than one log, so this would be a condensing situation. I would put the 8 as the exponent on the A, the 5 as the exponent on the B, and then because it's minus, it becomes division. So it'd be, God bless you, so it'd be A to the 8th over B to the 5th. Remember, when you're multiplying, it breaks apart as addition. If you're dividing, it breaks apart as subtraction. And if you're raising to a power, the power gets bumped to the front. So you're either going to go from this direction to this direction, or you could go back the other way if you're condensing. They work both ways.
Would you keep the ln in 27?
Yes. Yeah, so this would be ln a to the 8th minus ln b to the 5th, which is ln a to the 8th over b to the 5th.
Or could you put it in both the top and the bottom?
No. Because if it's on both, then it has to be subtraction. It's when you condense it that it goes down to 1. Good thing is it wouldn't be an answer choice.
What?
I said there won't be.
9 more hours to go, Miss Christizer. Where are we going? I have a test. Oh my gosh, I'm failing. Bye.
Bye. Who's giving a test today?
I know!
What class?
U.S. history? Grossi B. Grossi. Honors? Grossi! It's okay, I'm assessing the notes. Honors? Yeah.
I'd cry if I had a test today.
I would cry if I was the teacher with the test of grading today.
Yeah, I feel so bad for Mr. Sando. We had...
I in your answer choice. For real? Yeah. All right. 28, 29, and 30 are from 3/4 still logs. Okay. For 28, you want to make the base the same and then use the 1-to-1 property to solve. The 1-to-1 is where the base is the same, so you set the exponents equal to each other. For 29 and 30, for 29, you have to condense one side, then convert it into exponential to solve it. For 30, you have one log on either side of the equal sign, so you just use the 1-to-1 property. Anything that has log in its initial question, and you're solving for it, you have to make sure you check your answers. These are the ones that you cannot find the log of 0 and you cannot find the log of a negative number. It doesn't mean your answers can't be 0 or negative. But when you plug them back in, you can't be trying to find log of a 0 or log of a negative number.
How do you use the 1-to-1 for 30?
You literally just set these two equal to each other because they just have a log on either side. Yep. All right, there's 5. We got up to 5. Now we're getting warmer, right? Because this is chapter 4. This is our trig stuff, so hopefully this is a little bit more familiar.
Yeah.
Okay, hopefully. All right, you are going to get a unit circle, so that should kind of help you with a little bit of stuff. You're going to need to know where to plot an angle to identify the quadrant, and obviously it's not going to be a unit circle angle, okay? So if it's like negative, you would need to know where that goes. You're going to find coterminal, like 32. Remember, we would add and subtract 360 if it was in degrees, or add and subtract 2 pi if it's in radians. 33 comes from 4, 2. If you're given a coordinate point and you want to find one of the trig functions, the sine is the y, the cosine's the x, the tangent is the y over the x. And then the reciprocals you flip, or 1 over y is cosecant, 1 over x is secant, and x over y is cotangent. Right. (34) and 35. We saw these 2 places. We saw them both in 4-2 and again in 4-4. Obviously, you're going to get your unit circle, but you might want to add on when you get it. Like your all students take calculus. You might want to add your tangents to it. Ignore this. This was a question that came up that doesn't make any sense out of context. Yeah. So when it gives you, first of all, this won't be on the calculator. This would be unit circle base. But when you see the negative ones in your exponents, this is your inverse. So here, 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 this is your inverse. This comes from 4-7. And it was similar to 5-3, but you have to be careful what angles you pull. Because when we did the inverse, we restricted our unit circle like this, right? We said that the inverse for sine and tangent have to come from negative pi over 2 to positive pi over 2. So we used first quadrant and fourth quadrant, but only the negative angles in the fourth quadrant. And then for cosine, we use the natural first and second quadrant. So cosine doesn't change from 4-7 to 5-3, but sine and tangent do. For something like 39, now we're in right triangle trig stuff. So if you had 18 and 24, you would set up your triangle because that's not on your unit circle anymore. Cosine would be adjacent over, and this should be on the other side. Because that should be, oh no, that's right. Sorry, it's cosine is what you're looking for. The x is the 18, the 24 is the y, and then you're finding the cosine, so you have to find the hypotenuse. The numbers aren't that big without the calculator. This is bigger than the ones that are on your test. But also would be helpful is to know your triples, 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, and 8, 15, 17. There are going to be situations where you do have to use the Pythagorean theorem, like for number 40, we'd set up the triangle using the inner parentheses. So if the tangent of an angle is 2/9, then it means the opposite side is 2 and the adjacent side is 9. Then you'd have to find the missing side, which is the hypotenuse, and then set up your cosine based on that. It would be 2 over whatever you get for your hypotenuse. Ooh.
There's another triple that's 40, 41, 9.
9, 40, 41. Yeah, there's plenty more. They're just not as common. This would be 2 over the hypotenuse. I feel like you just said that, but you don't mean it. For the one we just did? So this says the tangent of an angle, that's what tan -1 means. Tangent of an angle is 2/9. So I drew a triangle opposite over hypotenuse. I mean opposite over adjacent, right? I would need that missing side, so I would do the Pythagorean theorem. And I would find whatever the hypotenuse is, and then to find the cosine, oh Lord, I know why I lost you, because this should be 9. Is that why? Yeah. Last time. So if it says tan of 2/9, this is saying find the tangent of this angle. 2/9 is an actual angle. You would have a calculator, you would hit tan 2/9. If it says tan -1 of 2/9, it's saying to find the angle where tangent is 2/9. So this is where you set up a triangle 2/9. Does that make sense? Yes. So if it says -1, you're looking for the angle. If it doesn't, then you're finding the tangent of that angle. So 2/9 is the angle. Okay, then 41 is from 5-4. Hopefully this is the most recent. This is your sum and difference. Again, I'm going to give you those formulas. And then comes the graphing portion. So 43 is from 1-4. This is your transformations. You might get quadratics. You might get square roots. You might get cubic. You might get absolute value, but they're all transformations. So whatever the sign is on the front, that plus and minus determines if it opens up or down. If the value next to the parentheses or next to the actual variable is in between 0 and 1, then it makes it wide or vertically shrunk. If it's bigger than 1, it's narrow or stretched. Whatever happens inside the parentheses causes a horizontal shift. If it's positive, it moves left. If it's negative, it moves right. And the K, if it's positive, it goes up. If it's negative, it moves down. So again, it could be a parabola. It could be a square root. It could be an x to the third. It could be absolute value. You would want to make sure you know how to do any of that with the transformations. And those are on the open-ended part. Yeah, and 45. They're all from the transformation stuff. All right, so what 4 or 5 is still 1, 4, but 46 and 47, these are your reciprocal functions, okay? This review only gives you cosecant and tangent. Also be prepared for secant and cotangent, okay? You could get any of those, which means you also have to know how to do sine and cosine, because that's how we do secant and cosecant. If it was sine and cosine, you only have to do one period, but if it's the cosecant, the secant, remember you're going to drop down the sides to give yourselves 4 asymptotes and 3 curves. So these are both from 4-6, but we built on 4-5 because 4-5 was the sine and cosine. These are what's on your test I have to give back to you tomorrow, so I would definitely make sure you practice those. For cosecant and secant, we graph sine and cosine. And for tangent and cotangent, we do that bx minus c equals, for tangent, it's negative pi over 2, positive pi over 2. Cotangent, it's 0 and pi. And then we subtract and add the period to get the 4 asymptotes. And then comes 5-1, which is the identities. So this is the other open-ended part. Graphs and then the identities. I'm going to give you that same reference sheet. So it continues 49, 50, 51. Those are still your identities. I'll give you that reference sheet that has them all. You just got to know how to use them. You can skip 52, 53. Those are double and half angles. We did not get to those. (52) and 53. And then 54 is technically when the calculator starts. So this would be at the beginning of your test, okay? It will start with these. So you've got your interest problems. I will actually give you what's highlighted there in pink, like it's in the directions. You just got to know which one to use. So P times 1 over R, 1 plus R over N to the NT is if you're doing it a certain number of times a year, like quarterly or weekly or monthly. And then PERT would be if it's continuously compounded. 55 is the only thing from the logs and the exponentials that you'll need your calculator for. So remember things like that. You'll factor, and then you'll have E equals a number, e to the x or whatever equals a number. And for those, you ln both sides of your equation. (56) and 57 are examples of right triangle trig word problems. Notice 56 has your degree minute second built in. Make sure you know how to enter that in the calculator. 56, like it says 40 or 24 degrees in 8 minutes. And then 58 and 59 are like, should be so easy, and yet if you're confused by what to push the buttons and what mode to be in, you're going to screw it up, so don't do that. 58 says to find the tan of an angle. So negative 1.6 is the angle. Is that degrees or radians? Radians, because there's no degree symbol. So my calculator would be in radians, and then I literally hit the normal tan button. Tan, negative 1.6. For 59, now we're doing the inverse, and those are always in radians. Good.
What's the same?
Like sine negative 1 is the same thing as arc sine. Or cosine negative 1 is the same thing as arc cosine.
How do you change the radians?
Mode, yep. And then it's like the fourth thing in the list. And you'll reset for me at the beginning, which means you'll put your calculator into radians. So here's like, today obviously I would start, you guys I see you the next 2 days, but you're not like, you don't have the pressure that C period has. I feel like C period's like all of a sudden it's here on Friday. So you have a little bit of breathing room, especially if you have an A and C you need to focus on. Work on this as much as you can, but don't stress yourself out about it just yet, okay? On tomorrow at 8 a.m., the solutions are going to be released. So you'll be able to go in and you'll see all the worked out solutions. And then also, I think I have a video that goes through the questions. And that's really for like over the weekend. I don't see you from Thursday until next Wednesday. So instead of sitting through, I'm not going to do this packet start to finish live with you in person, okay? Because some of you have no questions, right? If you're good on the whole first page, but your first question you don't understand is number 13, I don't want you to sit through me doing number 1 through 12. I'd like for you to have a video that you can skip to number 13 and you can watch number 13. That's the idea behind that, okay? So that, and then on Wednesday when I see you again, you can ask whatever questions you want. But for the next couple of days, you'll just be working on the packet in class. Yeah.
Are the last two both in radians?
Yes. Yeah. Questions? Okay, and then again, tomorrow I'll give back, I have your chapter 4 test, your quiz, I'll release the feedback at 3:30 today, and your 5 test, I'll release the feedback around 3:30 today once the makeups are taken. Your job is to make sure that any kind of makeup work or any kind of assignment that you have a question on is answered before tomorrow, okay? You have like 6 minutes if you want to do some work on this, or you could just take a break. Oh, go back.